Welcome back to question 4, where I show you how to solve word problems involving the cosine law. The question reads, a chord of a circle is a line segment with endpoints that both lie on the circumference of a circle. Shown on your screen right now is an illustration of that. Determine the measure of the central angle in degrees if the length of the chord intercepted by the central angle of a circle of radius 10 inches is 16.5 inches. Round the measure of the central angle to 1 decimal place. So let's go ahead and illustrate what's happening. I'll start off with a circle. And we have a chord. Let's put that in there. A chord from here to here, let's say. According to the question, the distance from here to here is 16.5 inches. The center of the circle is right here. And the reason why that's important is because the radius will be the same whether it's from here to here or from here to here. The radius is consistent all throughout a perfect circle. The angle that's made, we can call it the central angle theta. We need to find out what that is. We know that this is 10 inches. That's also 10 inches. And this is a perfect candidate for the cosine law, because the cosine law says that if you have side, 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 you should use it. Let me go ahead and label this A, B, and C just for reference sake. And the cosine law is little a is equal to b squared plus c squared. Notice that these are both lowercase, minus 2 times these two factors, b times c cosine theta. This is one version of the cosine law. There are two others. And from here, I'll substitute everything that we know. So little a is 16.5 to the power of 2. Notice that it's opposite of big A. Little b will be 10 squared, and so will be c, 10 squared, minus 2 times 10 times 10 times cosine theta. All we have to do now is isolate for cosine theta, then we can isolate for theta. So I'll take that term over. Also this one, I have 16.5 raised to the power of 2. I'm dropping the parentheses because this value is positive. There's no point for them. Minus 10 to the power of 2 minus 10 to the power of 2 is equal to, on the right side what remains is negative 2 times 10 times 10 times cosine theta. Okay, we can evaluate these now if you'd like to, or you can divide both sides by negative 2 and do it all at once later. And that's what I'll do. So I'm dividing both sides by all three of these factors. And the reason why I'm doing this is because they will cancel out if you do it this way. You see? They're all gone, leaving you only with cosine theta on the right side, which is exactly what we wanted to accomplish. I'll use my calculator now to find out what the answer to that is. And be very careful with how you input it. Notice that I'm starting off with parentheses. 16.5. Raise that to the power of 2 minus 10 raised to the power of 2 minus 10 raised to the power of 2, close parentheses, equals, divided by, at the bottom is negative 2 times 10 times 10, and I enclosed it all in parentheses. You want to do that as well. We end up with this as negative 0.36125. Make sure that you write down at least 4 digits if you are expected to show all your work. Now, I need the theta that represents this value. I can do that by clicking Shift, cosine. I get inverse cosine of the previous output that my calculator gave me. You click Answer, and we end up with 111.17. Remember, they want this to 1 decimal place. So, going back here, 1 decimal place is 0.1. The number next to it is 7. It's greater than 5. So 111.2. 111.2. And that is in degrees. And there you have it. That is how to solve word problems involving the cosine law.